Can you now? Is it a good
Hello,
time?
welcome to Data Analytics Colloquium. Today uh, we are so honored to have special guest speakers, Professor Michael Lewis-Beck and Professor Colin Lewis-Beck of University of Iowa, and their topic is about its topic is titled Forecasting 2020 U.S. Elections. Allow me to introduce Professor Michael Lewis-Beck and Professor Colin Lewis-Beck.
Well, we're really excited to be here in Taiwan and in Dallas, Texas, and in Iowa City at the same time. It's three places, and maybe four Hong Kong. So we're in four places. That's great, and I will say how happy I am that you asked me, and Colin will want to say something, and then we'll get going. Colin's gonna kick off the talk. So Colin will start talking now, and then we'll go back and forth. And so
Yeah.
here we go.
Sure. So yeah, thanks again, Carl and Harold, for having us. I wish we could actually be in Taiwan or Dallas. I'm in a windowless office in an empty department here in Iowa City. It would be a lot more fun to be with you guys. But this will be good, and I'm going to share. I just wanted you guys to see me, and I'm going to start sharing my screen here with the slides, and I'll go away, but I'll come back again here at the end. And so let me first just share my screen here.
Yeah, unfortunately, we can't do this split screen, so Colin will disappear behind the movie screen, but he'll return.
Okay. So all right. Okay, so this will be so Carl, just to make sure everyone can see the slides now on my screen.
Sure.
Okay, great.
Sure.
Yeah. So we'll again, thanks to everyone for having us, and how we're going to do the talk is sort of a joint thing where I'll talk for a little bit, Mike will go for a little bit, and then at the end, who knows, maybe even at the end we'll know the final results of the election. I just checked before we started here, and Georgia now, it's less than a tenth of a percentage difference between Trump and Biden. So maybe something exciting will happen here during our talk. We'll see. So just an overview of the talk today. So we're going to be presenting some, first broadly speaking, about different ways you can think about doing forecasting. There's a lot of different criteria that are important to think about when evaluating models, statistical models in general, but some are specifically in the context of doing forecasting. And then we're going to talk about three main forecasting approaches that get the most attention. The first one is going to be the political economy model, sometimes referred to as a structural model. The second one, which has probably gotten the most attention, is called the Economist Model, just because the Economist magazine has developed a model this election cycle. I think they were trying to steal some of the attention from Nate Silver and have their own competitive counterweight there. And so we'll talk about their approach, which is a different, more of a poll type of aggregation model. And then Mike will talk about a new approach that he's developed with some colleagues called citizen forecasting, which is based on this idea of Condorcet's jury theorem on the wisdom of the crowds. So those will be the main approaches we'll look at, and then we'll talk about the models. We did write these slides before the results to keep ourselves honest, and then we can see how they do or how poorly they do. And then we'll talk about the results, at least the results as they were this afternoon when we wrote this up. And then we'd like also at the end to finish with some questions from you guys, discussion. There's a lot to talk about here. You know, even when statistical models are good or bad, there's always things to discuss and pick apart. So that'll be fun. Okay. All right. So the first thing before we start talking about these different models are some considerations to think about, various criteria for judging models. One thing I think I like about statistics as opposed to mathematics is quite often there's many approaches to answer the same scientific question. where there's really only one way to take a derivative, and that's just sort of how it is. So I think it's a lot more fun to get into these debates where there isn't necessarily an optimal solution, but there are different criteria that we can judge these models against. And so the first thing we'll talk about is accuracy. You could think about this also as just goodness of fit. So how close, all these models we're trying to predict vote share, either electoral votes or popular vote. And so at the end of the day, we do have a truth that we can judge these models against. So we'll talk about closeness, the actual outcome. We'll talk about lead time. Oh, I'm hearing some typing on my end. I don't know if that's, is that?
Yeah, that's me, and I'm using this text box
okay.
to invite questions. Yeah.
Oh, okay.
Yeah.
Sorry. Just wanted to make sure I wasn't. Okay. Okay. We'll talk about lead time, which is a criterion that's specific to forecasting. So how early is the forecast made? So there's a trade-off in forecasting. As the longer you wait, as election day approaches, you do have more information, and you should be able to make a better forecast as you collect additional data. But at what point are you not really forecasting? Is it really that impressive if the day before the election you make a forecast? Is there some optimal lead time that balances these two factors of lead time versus accuracy? And so that's another criterion to be mindful of that we'll look at. And then we'll talk about parsimony. Sometimes people refer to this as Occam's razor, the principle of Occam's razor, which is so models are always, they're just approximations of how we think the world works, or how we think some mechanism is working in terms of generating the vote share for an incumbent candidate. But we also want to make sure we shave off any extraneous elements in order that the model really does get at the truth and is interpretable and concise. So we can decorate a model as sophisticated as we'd like, but sort of a tenet of all statistical modeling is this idea of parsimony. We don't want to add extraneous elements that aren't going to help explain the phenomenon, in this case, forecasting who's going to become the president that we don't need. And finally, we'll talk about transparency, which broadly just meaning generalizability of the model. If you present this model to another researcher, produce the same forecast in terms of reproducibility, but also, is this model something that could describe or predict new data or a different election? Or is it really something that maybe is overfit, or you're able to explain this one specific election really well, but you're not actually able to, the utility of the model doesn't go beyond that in terms of getting at some fundamental truths or mechanisms that drive voter behavior. So we'll start with the political economy model and keep these in mind as we go through these three different approaches. And I'll pass off now the next slide here to Mike, who will introduce the political economy model.
Hi. Okay, thanks, Colin. Now, in political science, in contrast to economics has a long tradition of forecasting, but in political science, forecasting has been frowned on. When I first started this work in the 80s, I couldn't get a journal to seriously read and publish my papers because they thought forecasting was just a game where you'd guess who was going to win a football game. Mm-hmm. So this has changed a great deal, and now political science forecasting, focusing on elections, is a thriving discipline, not only in the United States and Europe, but also all over the world. Every place that has elections is interested in forecasting. In fact, I'm editing a collection, a special issue on forecasting in Latin American countries. So if any of you have connections in Latin America or have a Latin American co-author and want to do a forecasting paper, please get in touch with me. So this is something that's moving across the globe of democratic systems, and this model, the political economy model, is in some ways a foundational model for all this work. It's perhaps the first model. I mean, I started working on this in 1982 and developed it, and then one of my readers said, that stuff you did in the early 80s is the best stuff you ever did. in terms of its accuracy. And so this is a model that was rolled out in 1984 and is actually, in terms of the desirable characteristics that Colin just reviewed, is quite promising. And it's a very, talk about Occam's razor, this is as simple as it gets, almost. I mean, it could have one independent variable. This has two independent variables. The dependent variable is the vote for the party in the White House, the incumbent party. And it says that the incumbent party, their vote share, this is their popular vote share, is a function of how popular the president is in the White House, the job approval, and then economic growth. So in terms of theory, and this is a theory-driven model, it says that the party in the White House will win votes if the president is judged to be good on political issues as well as economic issues. So presidential popularity picks up things that aren't economic, but also we have a separate measure on economic growth because we found it's very powerful and it has independent effects beyond the popularity. So these are the two variables. They're easily measured. They're consistently measured. We measure these well in advance of the election. We measure these things in midsummer. So in terms of lead time, you're going to see forecasts that were generated in the summer. The election's in November. These forecasts were actually released in the summertime. So next slide. Let's see. Okay. So the first variable is economic, that we're looking at here is economic growth. And on the x-axis, we have the percentage change in gross national product over the first 6 months of the election year. So that would mean from January to July of this year. And we have a time series from 1948 to 2016. So what we're trying to do here is predict the two-party popular vote share, that is the share of the Republican plus Democratic Party vote that will be received as the economy grows. How much more does the president or his party receive? And what we see here is there is a relationship. The relationship is actually, I guess you can't see the correlation on that. At the bottom, maybe you can anyway, the correlation here. This is a game you can play with your students. Those of you who are teaching, show them a scatter plot and have them guess the correlation. I mean, this is a game for nerds, statistical nerds like Colin and me. We play this game, but the correlation here is, and I'll just pause there. Okay, write it down. Those of you who write it down what you think the correlation is. Okay, it's 0.64. That's 0.64, and that's pretty good correlation. All right, so we see something's going on there, and if you well, we could return to this. Oh, so look at if you look at 2016. I guess when I touch that, you can't actually. Okay, well, if you look at 2016, okay, there's 2016, 2012 right next to it, 2008 below it. You know, these things are, most of the recent points are pretty close to the line. They're not all on the line. So this is an encouraging finding here. It also suggests that voters are retrospective. That is, they look back in the past and they look back at the recent past of the economy. So, all right, next slide. This is the same dependent variable, party of the White House and the share of the popular vote they receive as a function of how the approval of the president, and that's measured by a Gallup poll taken in July, which asks the respondents, do they approve of the president's handling of the job? This is a classic question. This was actually this was my 1982 paper, my very first paper, looking at this thing. And believe it or not, at the time when I did this paper, people did not believe the job popularity of a president had anything to do with their vote share of their party. That seems hard to imagine now, but in fact, that was a suspicious hypothesis back in the day. And what you see here is a very tight fit. Okay, I'll pause. I'll let you think about the correlation and then write it down, and I'll tell you in a little bit. What you see, the recent elections, 2012, 2016, are quite close to the line. 2008 is close to the line. So I'm only indicating that because to let you know that in recent elections, this variable has been very powerful and holding to the line. They're not aberrant cases. So the correlation here is an impressive 0.82. There's no variable that I've ever found that has a stronger relationship to vote choice, popular vote choice than economic growth. It's, presidential job approval. So it's very potent. So these are the two variables we're going to put now on the next slide. We're going to put them in a regression equation, the equation that we described verbally before in our political economy model. And what you see here is this, this is an ordinary least squares regression equation. Got a pretty good fit. You see the R square there. And what does this say? It says it's got, when the president gets his job approval goes up, the vote share goes up. And when the economy grows, the vote share goes up. So what do? We take this simple model and we just do some arithmetic. We see what the presidential approval rate is in July. Okay, July. In July, the presidential approval was 41%. You see that number on the screen. And then we looked at the growth rate in the first two quarters and as tallied in August. And you see it's a negative number, negative 4.14. That's non-annualized. That's just a negative growth rate over those first two quarters. If that were annualized, it would be twice that much. So we have a serious economic decline, and also we have a popularity number that's certainly not strong. So we have a moderate to weak president in terms of job approval. We have an economic situation which is severe. This gives a forecast. In August, we released this number of 43.3 percentage points for the Republicans in the White House for Trump. That is quite a low number. And next slide. So this is just a table which I won't dwell on. We have I've been using this model since '82, and here it's backfitted to 1948. It has predicted accurately the two-party popular vote share in the last 10 elections. The only elections it missed across this series were 1960, 1968, and 1976. And those of you who know American politics, those were very close, very unusual contests. Since 1976, it has always gotten the popular vote share winner correct. So we've got a string of 10 there. And that's makes us feel optimistic. My co-author, I should mention also, Charles Tien, he's my co-author on this. And this also I should mention, there's a bibliography at the end of the talk, but this paper on the political economy model, that is the title, and it is published and it's open access in the journal PS, Politics and Political Science, that journal. This paper is available, they're open, and it's open access. So you can see more detail if you read that paper. So we'll skip this slide now, and go to the next slide. So we take the popular vote, our estimate, which is 43.3, and then we put it in an equation for the electoral college vote. So this equation is we're regressing popular vote share on the electoral college share. And what you can see, and I just want you, those of you who teach statistics, this is a textbook example of a strong regression fit. I mean, every point is virtually on the line. So the statistical link between popular vote and electoral college vote is nearly perfect. Now, of course, it's not exactly perfect, but just for your own peace of mind or not, I mean, if you can see on the screen, 2016, 2012, 2008, all of those are very close to the line. So I will just make one point at this right now. The line fits the points very closely. Of course, if you win or lose basically depends on which side of the line you're on. So around 50%, if you're a little below that, you lose, or if you're a little above, you win. Anyway, I'm sure we'll return to this. I'm sure we'll have questions about this, but I want you to see how powerful that prediction is, and also to note does not appear visually to be any deterioration of the fit as we move through time or space. In fact, so anyway, we'll probably return to that. Okay, next slide. Okay, this is just a little thumbnail here about some. We're trying to be even-handed, so we're going to critique our models, the models we worked on, as well as the models we present. And these are right now. These are some limitations that Charles and I would readily concede that these are limitations. The sample size is small. It's the 18 elections since 1948. There is a lead time. We get one estimate. We don't get an estimate every day or even every month. We have one estimate. We believe in optimizing. We think there's an optimal time that you should forecast. And then there's the question of measuring the variables, especially the economic growth in 2020. And we'll return to that later. And so that's a quick look at the political economy model. And now Colin is going to be, and as Colin pointed out, this is what's called in the literature a structural model of forecasting. This is the major academic approach to forecasting. You build a regression equation driven by theory. You build that equation based on theory, and then you estimate it. That's a structural forecasting model. And now Colin's going to get into the what might call the rival approach to that. So Colin, I pass the baton to you.
Yeah. Okay. So let's. So I'm going to talk now about the Economist Model, or the E model for short. And this was a model that was started by Andrew Gelman, who's a big stats guy and political scientist. He started this with some people at The Economist, and it's somewhat of a hybrid in the sense that it has elements of the structural model that Mike talked about, using some fundamentals such as economic growth and popularity. But what makes it unique, or the addition to it, is it is heavily driven by state and national polls. And another feature is that it's estimated using a Bayesian framework. So the political economy model, we use OLS. You could use maximum likelihood as well. But this is a model that is really an extension of a model developed by Drew Linzer in 2013. He has a JASA paper where he applied or developed this model using 2008 election data. And it's a dynamic linear model in the sense that it's updated daily, and there is allowed to be sometimes dynamic linear models are referred to as state space models, where it's a Bayesian approach to time series where you allow the previous day's estimates to then affect the next day's estimates, etc. So, and how the structural component plays into this model is in the Bayesian framework, you have a prior distribution, the data or likelihood, and then you have a posterior distribution. And so before any polling data is received at the start of an election cycle in April or March, they use the structural component, like Mike just talked about, as their prior belief about the final election results. So that is incorporated as the prior, and then throughout the election cycle, forecasts are updated daily as new polling data comes in. And in some sense, you're just going to keep turning that Bayesian crank where you have, this prior distribution based on the structural component. You get some new polling data. You update that prior, you get a posterior, and then the next day's prior is the previous day's posterior. You might get some more polling data, and that just propagates forward all the way up to the election day. And so it's that's sort of the general framework. There's some more bells and whistles to it, but that's the primary idea. And as you get closer to election day, that polling data becomes stronger, has a greater influence on the estimates. And so what was sort of unique to the E-models approach is what they did, how they built upon the Linzer model from 2013 is they decorated it with some other features. They had hierarchical structure, so they're doing partial pooling where you can imagine that you have some national trends, some national polling trends, and then you have the 50 states. And so you can partially pool or borrow information across those states to fill in gaps if there are states that didn't have polls. And then they also allow for there to be some correlation structure between the states. And if you look at, I'll show you some of the output. And if you go to their website, they have more information about, they built a correlation structure using about 10 different variables, demographic information, economic information on states. So you might imagine that Minnesota and Iowa, if you talk to people from Iowa, they say we're much different from people from Minnesota, but there are a lot of similarities. And so if you allow for states that are similar with this composite of these different sort of demographic economic variables to share information, you can allow that correlation to help fill in gaps. So if Iowa has a poll that comes out that it really deviates from what is going on around it, such as Minnesota or Illinois polls, that's going to shrink those results back towards the overall mean. And then there's also, with this dynamic state, they're allowed to borrow information across time. So there's correlation or temporal correlation as you go forward, which will help smooth out big variability that you'll see day to day, especially in state polls, as opposed to national. You can, there's a lot of shoddy or sort of maybe not academic or really well done polls. Then if you don't smooth those, you're just going to get a lot of noise in the data, which will make it look like the results are really just jumping around from day to day, where in fact the fundamentals really aren't changing that drastically on a day-to-day basis. And so here is just a snippet from their website. So the Economist developed a website that you guys, I'm sure maybe many of you are familiar with it or looked at it throughout the election cycle, where every day you would get, and so I froze this here on August 27th, which is the same day that the political economy model forecast that Mike presented was based on data up to August 27th. And what you can see here is we have over time, starting from I think the beginning of April, you can see this retrospective smoothing going backwards in time, along with these uncertainty bands here. I believe these are 95% credible intervals for Biden and Trump. And then you can see the smoothing. These points are representing the actual individual polls. The solid line is the median of the posterior. And then you can, one thing that's nice about the state space models is you can do retrospective smoothing, and then you can also propagate forward. And so you can see then going to the right here, they project out, or they let the model propagate forward up until election day, and then come up with point estimates and uncertainty intervals for the day on the vote on election day. So this is, they predicted 54.3% for Biden on that August 27th, and the point estimate for Trump was 45.7. And then they also, so this is estimated using RSTAN, which is a Bayesian MCMC software that also Andrew Gelman is a part of and developing that. It's a popular MCMC sort of black box algorithm. I use it a lot for my work as well, and it's a very powerful software. And so that's that's what they used in order to get these estimates. and you can find some of their source code on their GitHub page. And so the nice thing with the Bayesian model is you get a rich set of posterior draws. You can look at, this is again the popular vote, but they also translate that into electoral votes, state by state predictions with uncertainty intervals. I believe this day here was 342 was the point estimate for Biden for electoral votes, and 196 for Trump. So some features, as I mentioned, the nice thing about the E model, as Mike said, one limitation of the structural model is, right, we have a sample size of 18 is our N, and right, we only have an election every 4 years. So, right, if you got to wait 4 more years to just get one more data point, right? You wait another 4 years, you get another data point. You know, that could take a long time to really sort of get a rich set of observations or information to fit these models. And so this is nice in the sense that you can really juice up the amount of information once you combine all of the data that's available from real-time polling, and that can help improve accuracy, and also allows you to jointly model both the structural and the polling data that comes in. And so you don't have to wait 4 more years to get another data point, right? Every day as polls come in, you get more information that in theory, if those polls are unbiased, should be helping to improve your forecast. And then another thing with the state space modeling approach, and I'm sure the economists like this, just every day it gets updated. So, you know, you get traffic to your site every day. I follow the Economist on Instagram, and they would always every day have it's like a new forecast happens. I mean, most of the time it's not really new. It's just sort of bouncing up and down a little bit, but it is fun to play with, and you can see retrospectively if there are any trends or changes over time that you don't get with the political economy model. Another thing the E model did in response, I think, to the 2016 polls, which were notoriously off, they tried to do some adjusting for polling biases, so partisan non-response. They judged the different polling companies. They had a quality of polling firm variable that they put on those to downweight polls that were known to be a little more shoddy than others. So they didn't completely, blindly say that all the polls are great. And so it's not purely just a polling aggregation. There's modeling going into the polls to try and fix some of these problems that they've been known to have. And as we'll see, it continue to have later on in the talk. And then also the model is, they monitor it over time. It's changed over time. Uncertainty bounds are updated as they get closer to election day, and as the polls increase and there are more and more polls that accumulate over time, those have a greater and greater influence on the point estimates and uncertainty intervals as you approach election day. So some limitations or things to think about is one thing is the model specification is kind of opaque. I mean, they don't, I guess as a statistician, when I read a paper or anything, I first just turn to the modeling section or the methodology section because I want to see what the actual model is written down in an equation form, with the deterministic component, the stochastic component. And they don't provide that, and then that could be possibly because it was devised for the economists. It's not for academic, an academic journal, but it does make it hard to see exactly what they're doing. And then they changed it over time, and it's not always clear why or what they did. So this is from their website on August 5th. They had this little addendum. We fixed a series of medium-sized bugs in the model that collectively caused too little uncertainty in our forecast. Which I guess there's two schools of thought to that. I mean, one is, as a forecaster, a lot of people don't like to do it because you can be wrong and that looks bad. But as a scientist, you say, well, this is my prediction, this is my model, I threw it out there, and we'll evaluate it at the end, and then make a judgment whether it's good and if it looks like it's not doing well, you go down with the ship and say, I'm a scientist, this is what I said. Or there's other schools of thought that says, well, don't just put your head down and if the model looks terrible, maybe you should be updating, or maybe there's assumptions that need to be fixed. And so we should be adjusting the model over time. So again, two schools of thought there. But that is one thing that is a limitation, I think, is that it is not as transparent about what's going on there. Also, the issue of lead time and forecasting in terms of an optimal time to predict, giving a forecast the day before the election really isn't that impressive. It's nice to see it change over time, but also at what point are you not really giving a forecast if you wait all the way up until the election day? So there's not a non-trivial, there's a lack of this non-trivial lead time, I would say, with the E model. And then finally, somewhat, this is getting back to the point about the first point here about the this monitoring and updating over time. There's an emphasis, I would say, on data mining and curve fitting more so than a structural or a mechanistic approach, in the sense that it is getting changed over time and updated, and is that something that could be replicable for another election, or is this something that you just tailored? This is going back to those criteria in terms of model considerations, or is this something that's really just overfit to this specific election? But if we try and reproduce something similar in the next election, maybe it won't work so well. So that's another concern I have is the overfitting or tinkering that might make it less generalizable than a structural approach. So we'll now turn to our third and also a very new approach to forecasting that Mike will talk about, some new work he's done with some co-authors here, which he's calling citizen forecasting.
There you go. So I'm not muted now. So let's take a look at that slide. Okay, just some background on citizen forecasting. This is something that I started with a grad student, and our first paper was in 1989 in the British Journal of Political Science. And we were using American National Election Study data. The approach is disarmingly simple. It's based on what citizens think about who's going to win. Now, I want to just emphasize this. It's very different from a vote intention question. A vote intention question asks the voter, who are you going to vote for? Vote intention is, who are you going to vote for? Vote expectation is, who do you think will win? Those are different. You may want to vote for X, but you think Y is going to win. And what we've found in this first paper was that in the United States, almost 2/3 of the time, on average, 2/3 of the public knew who was going to win in advance of the election. So we called this citizen forecasting, and it really didn't take off, or its launch was slow. It was sort of like the spruce goose, or kind of like, you see pigeons, they can hardly fly, and finally they fly. So we didn't get a lot of traction because partly it's disarmingly simple. Now I will leap ahead, since the first paper was in the British Journal of Political Science. We do have a paper which is coming out in the British Journal of Political Science, and it's been in the queue of accepted and pending publication for over 2 years, which I don't know why they have such a backlog, but the BJPS paper, which I've done with Andreas Murr and Mary Stegmeyer, two of my co-authors in this business. It's important that I tell you this for background. The British have more polling data on vote expectations. So we talk about vote expectations. Vote expectations mean who citizens think will win, as opposed to vote intentions. We did a paper and did a competition between the vote intentions variable and the vote expectations variable. Over 400 surveys for the United Kingdom, from the 1950s to the 2000s. So we had a long time series, 400 polls, over 400 polls, And what we show, and if you want a copy of this paper, I'll send it to you. But maybe by then it'll be out in BJPS. But in any case, what it shows clearly that this system of forecasting works much better than vote intention. Now that sounds counterintuitive, but it's truth. So Andreas Murr and I also did some forecasting works for the United Kingdom and showed that we could forecast elections there. Andreas Murr, who's at the University of Warwick, has done a lot of work on the US case as well as the UK. And the innovation in our current study, well, before I tell you that, the theory behind this, it is based on sampling data, but the sample does not have to be a probability sample. I underline that. It does not have to be a random sample. It has to be a sample that meets the Condorcet's jury theorem, which basically says if you have a group of people and they're not acting randomly, in other words, if they know something of relevance up to elections, the more people you have in that group, the more accurate there will be in forecasting. This goes back to Galton and his Wisdom of the Cows, where, and I have to tell you this story because I love this story. Galton went to the county fair in England in 1890, something like that, and there was this huge ox. And he asked the people at the county fair to judge the weight of this ox. Everybody made a guess. He took all of these guesses and averaged it, and it was right within a few pounds. Why was this right? Because they had a crowd. The crowd had wisdom. They were farm people. They knew how much, they knew this was an oxen. They knew how much more or less they thought it weighed. This is the idea. So you do not need a probability sample. This sometimes drives people crazy because I am really big on probability sampling, but in this case, not necessary. So, okay, next slide. What we did, this is never, okay, how do I say this? Okay, Andreas, I have to, Andreas is really a pioneer in this stuff. He took the ANES data. There is a question in most of the ANES surveys which asks, it is a probability sample in ANES, and you ask people, who do you think will win? Who will be elected president? That's in the ANES. Andreas was the first person to take all of those and use that to predict who won. He's got some papers on this. And what we saw was that, in fact, if you take respondents in the ANES and identify the state they're in, you can predict the state, how the state will go for the electoral vote. In other words, taking voters in the ANES sample from the state of Minnesota, they will tell you who they think is going to win in Minnesota. So this is really a revolutionary method because it's the first time. And then so what we did this for this election, 2016, in ex ante, not in ANES is ex post. No one has ever done this. No one has ever asked citizens in a state before the election who they think will win. So this is a brand new study. That's why we call it an experiment. So we call it a state-by-state experiment in citizen forecasting. So we sampled in every state in July a sample of over 2,500 people, targeting a sample size of about 60 in each state. So these respondents were asked, who do you think will be elected president in November? Just a general question. And then they were asked, which candidate for president do you think will win in this state? So next slide. Okay, if you look at this sample of about 2,500, if you look at it as a whole, slightly more than half of these people believe Biden would win, 51.35, okay? Now, if you look at the second question, who do you think will win your state? We get a different story. Now, so this is a really straightforward thing where I'm going to show you here. We just said for any state, it could be Wyoming. If over 50% of the people in Wyoming said Biden was going to win, then we said that state is called for Biden. And so we went through every state and calling it on the basis of if over 50% said the state was going to win. And so now I'm going to show you in the next slide a picture of that map. This is what it looked like. So if we look at, well, in the middle there, you see that Illinois has 20 on it. So that said, those people in Illinois said Biden was going to win, and that's 20 electoral votes to Biden. If you look at Florida, you see that it's dark gray, and that says that theirs is going to go to Trump. And so you see that we did this for every state. Let's see, now that I look at this for Michigan, okay, Michigan up in the middle, the top, it's 16 states, and it said Biden, so it got that one right. Now, so this is what we did here, and if you total these up, you get a forecast of 204 electoral votes for Biden and 334 for Trump. So let's see, this is, so this is in contrast, and we know it's in contrast, we're going to talk about that. This model, the political economy model, says it's going to be a blowout for Biden, and this model says it's going to be a blowout for Trump. Quite interesting. Next slide. Okay, so one thing you ask yourself, Andreas and I, we racked our brains, because I'm telling you, I mean, one thing we are is scientists. I mean, we're citizens, but we're scientists too. I mean, we have our values, but also one of our values is science. And because if we're not good scientists, we're really not worth much in terms of this kind of stuff. So we are very strict about scientific methods and the integrity of the project. We were very troubled, quite frankly, by this study because it was so different, and we did not expect it to happen. And the main reason we thought was because it was an MTurk sample. I think most of you know how MTurk is. It's respondents are paid respondents. They're paid a low wage to answer survey questions in Amazon. So this was immediately what we were concerned about, that people are going to say these people are just weird. I mean, they're not. And so we tried to assess the sample. And here's some characteristics. We found out we don't have that much data on the respondents because they're anonymous. One thing we know is that they have a bank account. They are actually living in the state. The survey company gives them an approval rating if they're a good respondent or not. We picked only people who had an approval rating of over 90%. You see they're interested in politics on a scale of 1 to 3. They score 2.5, so they pay attention to politics. The other thing, and this was really quite exciting for us, but also quite intriguing. We took, now, you know, we know in our MTurk sample that basically half the people said Biden would win, half the people said Trump would win. It was a line call in the sample, that general question for the nation. So we went to the YouGov poll. You all know YouGov. YouGov maybe there's hardly a polling operation that's more respected than YouGov. I know Carl can speak to that. So in YouGov for the same month, we did this survey in the month of July. Okay, YouGov, the YouGov so showed the same thing as we saw. Of the people who were willing to make a declaration, basically the same number expected Biden would win as Trump. So what we see is a result in the YouGov sample, which is virtually identical to on this item to the MTurk. MTurk and YouGov are virtually identical. So then we're thinking, oh my God, well this is something. And I will tell you. So we decided we had to replicate this study because, you know, after all, it's in July. Maybe something was wrong. Maybe everybody was at the beach drinking beer. We don't know. So we replicated it in October. Got basically the same sample size, the same instrument, ran it in October, and we got virtually the same results. So one thing I will tell you is that the results are stable across 2 time periods. Let's see, I think, is that the last slide on that column for now?
Yeah, the next is the results. Yeah.
Okay, so just to poise you for this, so what we've done here, we've looked at 3 very different models. And now we're going to look at the results as we have them, talk about what this means. And Colin's going to take over here.
Okay, so it's good. Yeah, we're meeting after the election. We can judge some of these directly with what we're seeing. So this is as of noon today. These are the numbers that I'd pulled down, that we'd pulled down. And this is the total popular vote share, 50.5% for Biden, 47.8% for Trump. And then if you just look 2-party popular vote share, 51.35 and 48.66 for Trump. So, and if you see all the models we've looked at, right, they didn't do great. But we can talk a little bit about things that, I mean, the good thing about modeling is either way, you can write a paper about how it was great or how it was wrong, right? So we'll talk a little bit about each of these. Mike, you want to talk about the PE one
Can you put the screen up there?
Yeah, this is the political economy model.
Yeah. Okay. It's coming. Something's coming. Are we there, Colin? Carl?
Yeah. Is it not? I can talk about it if it's not uploading on your screen. Are you? Yeah.
Okay. Yeah. No, I got it now. Great. Thanks. Okay. It was slow. So okay. Now this is exciting. This is exciting science. It's exciting politics, and it's very exciting science. So what Colin and I are doing now, we want to talk about strengths and weaknesses. After we looked at the results, what do we learn about this modeling? So I alluded to problems measuring the economy. And these problems were serious, not only for me, but for anybody. Most models, 90% of the structural models, if not more, have an economic variable in them. And this year, measuring that economic variable was quite challenging. And our case was no exception. It was very difficult to get a reliable measure of economic growth because it was an outlier. It was an extreme outlier. So as I showed, I mentioned, if we actually taken the real growth rate for the economy in the first 6 months, it would have been negative 5.5 over the 6-month period, negative 5.5. Now you noticed we used negative 4.14 because what we did was we thought that was that if we put in 5.5, it would be too much. It's assuming a linear extrapolation of the trend that we know, and we thought it was a bridge too far. We just couldn't believe that it was linear all the way out into outer space because in the data set, the biggest negative growth from 1948 to 2016, we looked at all that time span, and the biggest negative growth for any election year was negative 1.38. So in terms of the known world, and Ed Tufte talked about this, the dangers of extrapolating beyond the known data. So those of you who teach methodology or use methodology, we know we're not supposed to do this. When we go beyond the data we know, we're really in outer space. We don't know. Could be Martians out there. So we said, let's just be, and there's a common trimming technique, which actually has the very elegant name of Windsorizing. It's an old word, but it used to be a car wax named Windsor. So you wax your car. But anyway, Windsorizing means you take that outlier and you don't throw it away because you want to keep that information. You set that outlier next to the most extreme data point in your data set. So we changed the negative 4.14 to negative 1.38, which was simply making it equivalent in weight to the most extreme negative growth that we had had in that period. We made that adjustment. Now, if you do that, which is a measurement adjustment, and I want to point out that the E-model also, all the models who had the economy and had to make some sort of adjustment. If you do what we did, what I just told you, and then you put a 95% confidence interval around the electoral vote share, then our result falls within that confidence interval. In other words, our estimate, once we do that, says the model is working. It would call, of course, the model does call for a Trump defeat, and that would be clearer. It would be clearer if we did it that way, and also it would not be as dramatic a defeat. So that suggests to me, and Colin mentioned this thing, is you're finding only generalizable to your data set, which is really not generalizable at all, or can you go beyond your data set? This is important because this suggests in crisis situations where you have extreme jumps positively or negatively in growth, that's not going to be a linear extrapolation. You have to, people can only absorb so much bad. So that's quite a useful lesson. The second thing we learned here is about Trump's, the second bullet point, or the last bullet point, Trump's unusual popularity pattern. Now, most of you know this. Trump has his curve, his popularity curve is unique in the post-World War II period in that there's very little fluctuation in it. It's almost a flat line. There's some fluctuation. That's quite unusual. And for forecasting purposes, that makes you suspicious about what's going on. Is it, the Trump's base, but that's the downside. On the good side, the Trump popularity pattern is unusual also in that it never gets even close, virtually never gets close to 50. And let's see, in that first paper I wrote in 1982, I had the popularity model for election forecasting, and it was if the president is over 50% popular, he will win, or she. If the president is under 50%, they will never win. So Trump was at 41. He was, always in the low 40s, never got out of the low 40s. So he actually meets that simple litmus test of the popularity being too far below 50 to win, according to our model. That very simple, seat of the pants model almost tells you that Trump would suggest you that Trump would lose. So those are some things we learned from the political economy model. And I think now, let's see, Colin, you're going to talk about the E model.
Yep. So some things from the E model. And I think I like this quote. This is from a physicist, but if your experiment needs a statistician, you need a better experiment. And just to say that the polling, basically, we've seen that the data, the state and the national polls are still not representative sampling. And so you can use fancy, it's the E model valiantly tries to use all these fancy statistical techniques to adjust for these polls. In the end, right, it's garbage in, garbage out in some sense, right? If you have bad data, you can only adjust it so much, and really what we need is to figure out, or to be getting better representative samples to do these forecasts, because now we've seen 2016 was off, and then this election cycle, even right up until the end, most of the national polls had Biden up by 10 points, some even higher, 12 points, and that clearly those were wrong. And I think that hurts the E model too, because as I said, it not only was not able to fully correct and make these adjustments, but as election day approaches, it's relying more heavily on this polling data. And so it's hard to break out of that if you're, all of the the data that you're putting in there really is not a representative sample of the population, it's going to be really hard to make inference. And so, again, something that will, Mike's talked about this idea of representative polling, that we have a lot of polls now that are done, using convenience sampling, online sort of polling. They're cheap to run, and the news media likes them because every day you can put out a new poll. They can quote a new poll. But I think that all these polls are actually doing a disservice because they're done so poorly. We'd be better off doing less polls and perhaps spending some money to do some real proper probability-based polling to avoid, another cycle where the results, as we've seen coming in the last couple of days, don't really connect with the the forecasts that these two approaches put forward. So I think we'll pause or stop here for now and
what about the next slide, Colin? We want to hold on that one?
Oh, I think we were going to wait for that one till the end.
Okay, fair enough.
And then maybe take questions now or comments, open it up to discussion.
Yeah, we've got a surprise ending for you. That's Colin's good idea. We're going to hold that back. Okay, yeah, we'll take questions now.
Yeah, looks like we have some bonus saved to the end. Yeah. All right. Thank you. This is really impressive presentation. And look at three separate models. Now, I'd like to invite questions from the floor in Taiwan and also in US and Hong Kong. Excuse me. I just taught a 3-hour class before this. Now, I also like to welcome our colleague, Professor Stan Wong from Hong Kong Polytechnic University, and his students. And now he just came aboard. I think he came aboard early on. I forgot to introduce him. So Stan or students from Polytechnic University or in Hong Kong, please feel free to ask questions. Either you can do it, type it up, or in the conversation, or you can just bring it up. And I think I would just take advantage of my co-host position to talk about this as the first few questions. So I am really impressed with your MTurk model, and you call it citizen forecasting. Of course, now I feel operation questions. How much do you spend on the MTurks, and also how do you operate this by state, right?
Okay. Yeah. Well, this is really interesting, Carl. I'm glad you asked this because this is something Andreas and I and Mary, and also Charles Tien, my other co-author, he's done some of this work. We really, the thing we realized we needed to do in Britain and in the US was we needed to get down to the constituency level, not just the national level. We need to get down to the, like in the US it's this, well, in Britain it's the constituency level, but in the US, especially with the electoral college system, we really had to get into the states. And we explored different avenues. We tried to find something in Google, because Google launches certain surveys state by state, but there's too many restrictions. I mean, we couldn't, it was too limiting to use Google for because of the things they let you do and the things they didn't tell you. So we couldn't do Google. And we stumbled on MTurk a little bit. It was foreign to us. Some people, so we actually did a dry run on MTurk in 2016, but we didn't go down to the state level. There was just a pilot. We didn't really do much, but we decided we would do the state level. And now Andreas is, I know you'll want to do this, Carl. Andreas has the detail work. I mean, you'll want to contact Andreas on the detail work because he knows the nuts and bolts better than me. But basically, okay, the encouraging thing about the sample is these people who answer the questions are paid. They are registered workers. They are known to be. They actually have bank accounts in the state. They live in the state. They are vetted in terms of a ranking of how. In other words, they do the work, so they get rated, and there's very little demographics. Like we don't have any SES data. We have no SES data. We do have a political interest item. What I told you, we do have, and somebody said. There is a study Andreas found, like 2012, someone did a study of MTurk workers, and they found out they were all liberal Democrats. Because someone, after we did this study, they said they're all Trumpites. Well, in 2012, they were all liberal Democrat. I mean, not all, but so we have a slim. So here was our method. We thought we were going to challenge this sample in every way we can as good scientists, because this seems important, and the only, the thing that we made us, well, we couldn't find that Achilles heel, that one big flaw that once we found that, everybody say, well, obviously that's the reason they got this crazy forecast. But anyway, you can do this, and the total cost was for we had, so we ran it over the period of about 3 weeks in July and about 3 weeks in October, and you're getting daily samples. We targeted each state. You don't need a probability sample, but we did try to get at least a minimum of 30. That was always our goal before we stopped in a state. We try to get more than 30, but in terms of the normal distribution, 30 is a good number. So it's just about it's careful, but it doesn't cost. I know here's what you really want to know. It doesn't cost a lot of money. It costs.
Yeah, no. It could be,
This study, 2,500 people, cost us $850, less than $1,000. And the same one in July, it was like 800. I think it was $850. So that's not a lot of money, really.
Not bad. Yeah.
And so that's. I would now, so I still, well, actually, I'll just say this since we're talking about this. I am disquieted. Well, okay, I mean, I have been working on the citizen forecasting thing for a long time, and actually, the scientific power of the approach is formidable. I mean, I could give you paper after paper where this method works. And I think in this case, it did not work. I mean, okay, the good news is it worked this way. It made us aware that this election was going to be a lot closer than anybody thought. It's much more information. If you look at this result, and we did it twice, July and October, you look at this result and you compare it to what's going on in the polls in the New York Times, the paper, you think something is crazy here. Because this study is saying, Trump is going to win by a lot. Well, so you have to say, at minimum, and we did a blog post, a London School of Economics blog post that just came out. You could look it up. Came out a week ago on the second study. And our conclusion in that was what this tells the voter, tells the public, at minimum, this race is going to be a lot closer than people think. So this is something we learned, which was very helpful. Now, having said that, the other thing I've learned, I think there is something with the MTurk that's not good for this, and so I have to conclude that as helpful as that was, it's not the way to do this. I mean, this particular, it's too far off, because in general, this system, like, put it this way, you take almost any sample that's not done in this, which I have to call a kind of a peculiar way. We have low paid workers. They're paid very poorly. But if you take a sample off the shelf, I mean, so take, for example, ANES or the British election study. Andreas did this. You take the people and identify them by constituency or identify them by city. it's not, no, it's no longer a probability sample. It's a probability sample at the national level. The national draw is probability, random sample based. But when you break it by states, stratification to make it probabilistic by state. So that's really interesting. So that's an example of power. The French have used this too. So it's a very powerful and low cost strategy. And I would just say to you, because I know you're going to go out and do this, I would not. You might want to do a pilot on the MTurk, but also there are approaches that might be similar that you could find. I hope that's you.
Yeah, and actually, Harold and I, we have a survey project supported by UTD. Now we did a national sample about 2,500. Now we did the first wave, and if we look at our data, which is closer to like a real clear politics, and it's still like a 55-44, which is way off now, of course. But we will look closer at data, and actually that is also determined by the timing, the poll. So we did that. Most of the data come from October 13, 14 within 2-day period. Then after then, so we see it's much closer than originally projected. So timing matters too. But I really like your theory that voting intention is different from voting expectation, because voting expectation, if you think about it like some Bayesian thinking, so you vote for one thing, vote for one candidate is one thing, but you incorporate the information collect, you induce, then you come up with your own expectation, so which is adjusted with the information you have. So that it makes more sense, just like an expert or a farmer looking at the oxen. So, and from his previous information, from looking at information, also looking at what maybe how others are weighing it. So these are the additional information that is making this guess much more informed. Because your voting intention could be just out of your own perception, could be subjective. Now you incorporate this prior information or other information, then you have a more closer to reality estimation. Now, Colin, can you move your slide to the map with the citizen forecast? I think this is really interesting map. Thank you very much. Yeah. This
one idea too, to your point, Carl, about the prior, or like, are you educated? If you've seen the oxen, you know what, you have some information that you're bringing to that. Is that another possibility? Was maybe these people are just not politically aware really of much of what's going on, and so another idea that we talked about was having a question on there from each state to ask the person the governor of your state is, or something where you could get an idea, about just, are they even aware at all or follow politics at all, that so they could bring some expert information or some knowledge in, versus just clicking the button but not really knowing anything about what's happening politically in the state.
Yes, exactly. I think one question here, of course, immediately coming from this map is why Californians will
yeah, that's insane.
Will expect Trump to win. Maybe this is something that this off. If you take that 55 off, that could be much closer to the current situation. We do not know exactly. Now, I believe it could be some data discrepancy about this election result. Now it's still being counted. But if you take that off, and maybe that is the anomaly. And
this jumped out right at us. And one thing that we did, and this was quite difficult, we put confidence intervals around each state estimate. So the state estimate for California was I recall it was 46. I mean, no, it was 50, 53 or something. If you put a confidence band around that, it could easily have been on the other side. It was on the positive side for Trump, but it was, if you put a confidence interval around the estimate, you couldn't rule out that it was less than 50. So, but nevertheless, that it is. There's a few other. Well, that's the big one that you people. And I'll tell you, we had somebody. That's the one that makes you skeptical. The California result. Yeah.
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 Otherwise, and maybe Florida is correctly predicted. Now, I do not want to take too much time now, and I think I need to pass on to Taipei side. Peter, do you have questions? And also, I want to invite Professor Chen, Team Chen, and also Professor Stan Wong. If they have any questions, please bring it forward. Thank you. Peter?
All right, let me ask a question right here as is from the floor. For the 2016 and the 2020 elections, people have been talking about the shy Trump. So whether this is whether it's in the PE model, E model, or citizen forecasting, do you think it is an issue here, or you have already factored in this, the shy Trump voters? Because it's all about poll, right? Opinion poll and with MTurk. So what do you think about this?
Colin, do you want to answer that, or you want me to?
Why don't you go first, and then I'll add on some things.
Okay. This is a long-standing argument about the shy Trump voters. It's a similar argument that they made in France about National Front voters, that people don't want to admit that they're for the National Front, or they don't want to admit they're for Trump. But in fact, the evidence is slim to none that they're shy, that Trump voters are actually shy. And they haven't been able to support that. I mean, here's what's going on in the polls. Well, first thing, Paul Snyderman, who spent most of his scholarly life studying racism, he told me one day, he said, you know, racists are not afraid to say they're racist because they believe that it's true what they're saying. So Paul said, you know, a bigot is a bigot. What he or she says, they believe it, and so they're not ashamed. They're not shy. They'll tell you such and such a group is lazy, or such and such a group is stupid. And I believe that's the case from my own experience. People are, if they have conviction, they're not afraid to show it. Furthermore, things like say racism or a prejudice against some kind of a group, what we know now in terms of survey research, we can ask questions, structure them in such a way that we can get that information from them. I mean, we can get around the social desirability thing. That is not a big problem. Mm-hmm. The other thing, I think the reason the shy Trump argument is compatible with bad polling, you know, the bad polling is underestimating the Trump vote because it's bad polling. A lot of the Trump supporters are not on the internet. That's a key thing. At least 15% of the American public, they do not have internet. A lot of these people are Trump people. They've not.
And most of the polls that, if you look at the polls that they use for the E model, most of them are online polls too. So yeah.
I mean, in everyday.
Indeed, including ours. Yeah.
Everyday people in the towns in Iowa and around, they're not like us. They're not spend half their day looking at a computer screen. They really don't. I mean, they go milk the cows or something. I mean, this is a huge problem. Okay.
And the E model does do some partisan non-response correction in their model. I don't remember exactly mathematically how they do it, but they do address that. But I don't think it was, clearly not enough to correct, given the data that they were given in the polls.
Yep.
Thank you.
Peter, you have more questions, or maybe we can invite any questions from Hong Kong side or from Professor Tim Chen.
hello.
Oh,
Our
Tim, go ahead.
guest. Hello, our guest
Right.
speakers, and thank you for the insightful presentations. I have a question. Since you mentioned there's about 15% of the uh, uh, Trump supporter do not use frequently with the internet, and then how do we sample them, or how can we assess those the intention of the voters? That's my first question, because that can explain why in the year of 2016 and this year's, and we can see the strong Trump supporter flock into the ballot booth to vote for the Donald Trump, and which means his support getting very strong. My second question would be, whenever we use these citizen models, um, how much, where those citizens gain their political knowledge or information from? Uh, because it may become some kind of bias. For instance, in Taiwan, Taiwan has been a long-term support of the Donald Trump to some extent. Uh, some of my students, they support, they favor of the Donald Trump. But however, whenever you ask them to forecast, they still think Donald Trump is going to win. Even they have not very much about the knowledge about electoral vote or American elections. So I'm talking about, where do they gain those political information or knowledge? Thank you.
So one thing about the citizen forecasting from the, I mean, that's a good question about, if you live in Iowa City, so Johnson County is the most liberal county in the state of Iowa, and Iowa City is the most liberal city in Johnson County. And so you talk to people, Bernie won, in the primary here, Bernie got, I think at my caucus, he got, 95% of the people went for Bernie. And Joe Biden didn't even have a quorum. He didn't even get enough people to form a group. And so then you see, like, but these are all people that live in this super liberal university town, and then then they're apoplectic when Joe Biden just sweeps everything, and or same with Trump, because it's it's a very insular community. And so you're right that there is some, and Mary Stegmeyer, and the work that she's done on the paper she's done on wisdoms of the crowds, is she did some network analysis that showed that the citizen forecasting does perform worse when you do have people that are very insular, or have a very small group of people that they talk to, or stuff that they read. And so there is an importance to having some diversity in terms of people you interact with, things you read. And she did some network analysis to show that you were right. I mean, if you're just in the coffee shop in downtown Iowa City all day, you're like, how did Ralph Nader not win in 2000, right? Like, that's because everyone you talk to thinks that should be true. But if you broaden your horizons, or you have a broader network of people, the citizen forecasting works a lot better.
Also, I just one technical thing. This is a linguistic thing. There's an ongoing confusion in the English language between 50 and 15. They often sound the same. And I said 15, 15%, not 50. I think you said 50, 50. It's 15, 15, not 50.
15, yes.
Yeah, so, yeah, but, right. So it's, anyway, I hope that what I would say to you, if you've got students, one thing, the citizen forecasting strategy is low cost, and try it out. It really works. It generally works quite well. It doesn't. I mean, it wasn't a disaster. Well, it did as well here as the vote intention polls. Vote intention and vote expectations perform in a mediocre way this time.
And I think to the other point about how do you reach those people that don't have internet, if those are Trump voters, I mean, you can do, if you have sampling units, geographic sampling units, and you have people's addresses, you can go and randomize within those sampling units and, go door to door and try and, reach those people. But the reason why that's not done is that's expensive, right? People to go out and do that, right? It costs thousands and thousands of dollars, and the Des Moines a newspaper, is not going to spend the money to do that, right? If they're going to try and spend $1,000 to do their poll, not actually $1 million like an ANES poll or something.
But actually, on this point, Colin, that's a great thing, and this is a really important point. The problem with polling these days is that people do not sample from a list. The way they used to get lists is they would make a geographic map. You have to have a list of people. So you make a geographic map, you go ever smaller units until you're actually in the neighborhood writing down addresses. Now, I have done this kind of survey. I spent a lot of time in Latin America, and I've done surveys in Peru and in Ecuador, where you start, you make a map of the constituency, and then you make within the constituency, you draw blocks and then city blocks and then neighborhoods and then houses. And then at the end of the day, you have a list. Now, in Ecuador and in Peru, this is not expensive. I don't know what things cost in Taiwan, but these kinds of the advantage of this door-to-door stuff is you get a list of addresses and there are people there, and you can say that's a house where somebody lives, or that's an apartment, somebody lives there. You can do that. And in countries like, actually, this is a good point. I mean, there are many countries of the world that are democracies, the cost of this is not as much in some countries as others. So of course it takes work. You've got to have your interview team knocking on doors, going in neighborhoods, but that's the way it used to be done all the time. So okay, I don't know how expensive would that be in Taiwan or Hong Kong? Hong Kong, it might be more. I mean, right? So I don't know.
Carl,
well,
I have one more question.
Sure, go ahead, Tim.
If we're talking about economic voters, from the retrospective perspective, do you think most of the Trump supporters think economic condition is very well, or do they feel they are better off than 4 years ago? And does it related to most of the strong supporters, they will support Donald Trump no matter what? Because Professor Lewis-Beck, you mentioned Donald Trump has very unusual support, no matter what, flat support. So does that mean no matter economic condition, they would support Donald Trump whatsoever? Thank you.
Yeah. Well, you are right in the sense that his pattern of support is very unusual. And he does have a base. He does have a base of supporters that will support him. As he said, remember when he said, I could shoot someone in downtown New York City and I wouldn't get arrested. I mean, he does most things. He would get, they're criminal things. He does criminal things. People say, that's okay. There is a group. However, that group is not as big as he would like to think it is. So, look at it this way. That strategy that he's followed is actually a losing strategy because he's losing. And he's going to lose this race. But you're right about that resistance. And now the other thing is that in terms of economic voting, which makes it very difficult this year, is that the economy has had unprecedented swings. All of a sudden, and this is like had uneven effects. So if you're a professional person now, you might be able to buy a house because you can't spend money on everything else, so you buy a house. But if you're a poor person, you can't have anything. So there's all these strange things going on. So it's really, the effect is, there's a massive negative effect, but it's like a roller coaster, up and down, it's all over the place. People are quite confused. But I have seen a study about COVID, and people who got COVID and lost their jobs this was a systematic scientific study. People who got COVID and lost their jobs because of COVID voted against, were more likely to vote against Trump. And that's what you would expect.
Yes.
But it is confused now, very, like, that's our example. Well, you know, we had to adjust, we made an adjustment for the economy, and also in the Economist model, here's what they did. They said, well, we will say that the economic effect of COVID is 40% greater than the effect of the Great Recession. Well, that's really seat of the pants, you know. We would take the Great Recession, and say, well, this one is 40% worse. I think that's wrong myself. I think it's 3 times worse than that. But it's there's a honest people or economists can argue about, you know, that kind of thing. But it is quite, and we're trying to unravel that now. But it makes our jobs exciting, right? We live in exciting times, whether we want it or not.
Thank you. Thank you very much.
Thank you.
Great. Allow me to read out a question from one of our graduate students, and Armand Kafai. And he said, I think that you may have addressed this question, but I still want to read it out. And I know you all mentioned it toward the end, but how specifically would you look to improve polling? It seems like on a public perception scale, the polls will take another credibility hit, as they did in 2016. I think the citizen forecasting method is very interesting. I think this is good. I think you address this, and I think maybe that is maybe Colin and Michael also want to talk more about polling industry future and how that could be improved, and to win the trust of the public, win back the trust of the public.
Yeah, I think I think that there's too many polls, and I think, you know, there's hundreds and hundreds of polls, and I think one thing would be just to do a lot less polling, but just have a few polls that are actually done scientifically rather than you know, journalistically, or you know, by some of these you know, poll shops that don't really have methodological training when they're collecting the samples. I mean, then the problem is, you know, them getting the money to do that. But hopefully, maybe after 2 election cycles of polls being completely off the, I don't know, the Democratic Party, or, you know, or there'd be an organization who'd be willing to properly fund, you know, probability-based sampling polls. But I think partly, yeah, just doing less. I think less is more in that sense, because I think now these polls really just cloud. They add more noise, you know, and there's no signal there. It's just a lot of noise that gets added throughout the election cycle.
I agree. I mean, it's unfortunate, but, you know, it's the emperor has no clothes. I mean, the way you do sampling is it's clear. It's math. It's mathematics. The founder of sampling, of modern sampling, Leslie Kish at the University of Michigan, and he wrote the 1965 survey sampling. It's the Bible. It tells you how to do a sample, and it's just applying the math. It's mathematics, and he tells you how to use this mathematics to get a scientific sample. And it starts with you have to have some way to get a list, an enumerated list to draw from. You got an enumerated list, and then you sample it randomly. That's all you have to do, but that's huge. But that, if you don't do that, then you're just putting your finger in the wind. It's complete guesswork. It's that simple and that complicated, and people don't want to face that because it's the costs. It's the costs that are being driven up. So really, like Colin said, if we had fewer polls but they were done correctly, we would learn more. Now think about all the people who have been misled and have had anxieties, or they didn't vote. Maybe they didn't vote because they say, "Oh, Biden's gonna have it. He's got it in the bag." You know, and it creates. We know so many people who are they're physically sick because they worry all the time. I have a friend, Colin and I both have the same friend. He told us he was going to go into his basement on election day and not come out for at least 24 hours. He was going to his basement, wasn't going to let his wife come and tell him anything. He was going to take a bottle of cognac to his basement and sit down there, not listen to the radio or anything, nothing, because he was just so upset. I mean, and I don't know if he's out of his basement yet. I mean, we really don't know. Also, he's from Georgia, which means he's even more nervous. So, yeah. So maybe we should.
And the thing too about the polls, the biased polls, is it's not something either that can be fixed really by a larger sample size. So,
right.
As n runs to infinity, if you have a non-representative sample, that bias doesn't go away as n gets large. So, I think some people like, Facebook or these places that say, well, we don't need a representative sample because we have, 100 million observations in our data set, or whatever, some large, n equals, really large number. And it's like, well, if that's not going to fix a sample, that's not going to, get rid of sampling problems just by having a large n. That bias doesn't go away. We know that, mathematically that's not going to fix it.
Mm-hmm.
Yeah.
Yeah, this is what the Google food trend fell big time. That is a Nature article. And allow me to invite any students from the floor, maybe Peter. Do you have to pose any questions?
Yeah, actually, there are a couple of short questions, but how about I suggest that we still have one last slide to go, right? And
right, yeah.
I read this about 11:47 right here. So how about Colin finish the last slide, and then if there's still time, and then I will just add 2 more questions to this.
Yeah, so this last slide is a little bit tongue-in-cheek, but it speaks to another modeling approach. It's a little bit back of the envelope. We just put this together this afternoon for fun. But if if you're familiar, I'm sure you are, Carl, and a lot of your audience with ensemble modeling, where you combine a lot of different, it's sort of a little bit related to citizen forecast in the sense of you combine polls together. And if you combine polls that have certain biases, right, one direction on average, those will produce a better estimate than any of the individual forecasts. And so that could be another future approach. And just as a fun thing, I don't know, we took, if you do take the political economy and citizen forecast, the political economy was biased, a landslide for Biden. Citizen forecasting was a landslide for Trump. If you just take a simple average of those, you get 201 electoral votes for Trump, which is pretty close to his current share. So that was just a sort of fun thing, but that could be another approach too that we know works well in the statistical literature. And then I have here, if you're interested in some of the additional work that's been done on citizen forecasting, on the E-model, on the political economy model. Here's a list of the references, the articles we cited, if you want to read more on any of those things. So thank you, and yeah, we can if there's time, we can take another final question too.
So, Carl, do you have additional questions to ask?
Yeah, you go ahead, please. You go ahead, please.
Together. Excuse me. I just have very, very short questions here, and maybe after this, and Carl, you have more questions, we combine them, and Professor Lewis-Beck, you can all answer it all together. One of them is that how do you deal with the lead time issue? Because of course, if from a PE model and we see all the trends, and you take the data as day-by-day data, so the aggregate. So it's the lead time issue is kind of solved, but for using the public poll, either Gallup or some other poll data, and then the lead time seems to be a factor. So the question is about how to deal with the lead time issue. And then the other one is about, I think it's about the presidential popularity, because it talks about the Trump is atypical from what we perceived or expected a president was like. So some said it's a phenomenon that people either like it, or, I mean, love him or hate him. So does that affect, kind of bipolar situation here? So does that, is that an issue here? Yeah, that's the two short questions. Carl, do you have?
Let me see my
questions?
side here. Let me see if anyone is posing questions from the graduate students here, UTD. No, I don't. I think I would just have Mike and Colin do the to wrap up and also address these questions, maybe.
Okay.
Please. Yeah.
Colin, go ahead.
So I'll talk about the second one maybe, and then in terms of Trump, I mean, I was talking with my dad about this afternoon. It's not, there are leaders like him, he's bombastic and an outlier in the US, but Berlusconi in Italy, we were talking this afternoon, really is like kind of their Trump. I mean, and he was similar in that he was a criminal and he could do whatever he wanted and be a lech, and he was around for 10 years or more, and people loved him because he was exciting and a celebrity. So it is a the models, these models, especially the structural models, sort of assume the process. There's a mechanism that leads to these forecasts, and that if that process changes, then yeah, maybe the model needs to reflect that. But with just an n of 1, it's sort of hard to say, right? Is this in terms of modeling, we need replication to really be able to account for that. But so we'll see. But I mean, it isn't, Trump's not the first democracy to have this. The U.S. isn't the first democracy to have a type of leader like Trump.
Mm-hmm.
Yeah. On that, actually, that's interesting. Every democracy, the polls always have a question about what's called popularity, but it's measured in different ways in virtually every country. Sometimes it's a question about, are you satisfied with the president? Sometimes it's a question about, do you trust them? Sometimes it's a question of, do you have confidence in them? And sometimes, like in the US case, it's, do you approve of their job? Now, if you ask if you approve of your job, that is a question about performance. That's about policy. Are you doing a good job in your job as a president? That's policy. Some of these other questions are more about personality, or maybe we should ask a question that's more just, they actually do this. It's likability, the feeling thermometers. So, maybe they're low. Trump might be, let's say a president might be low on performance, but high on personality. Because, the Berlusconi example, and I've heard this made about Trump, he is entertaining. People laugh. They go to his rallies. They have fun. It's like Berlusconi was spectacular. Now, for everyday people, you think of this, what's their benefit from being a citizen? One of the benefits is entertainment. They get free entertainment. It's circuses in Rome. If you think about that, that's not so far-fetched. The other thing that you raised is the lead time. Now, in general, it's true that the closer you are, the better you can forecast. However, I want to give an analogy. Many of you probably, you all know how to play darts. You got a board, there's a bullseye, you throw the darts. Your accuracy will improve the closer and closer you get to the board, until the board is in your face. When the board is in your face, accuracy is less. So you can get too close to that dartboard and actually not be as accurate. And we see this in polling often. So in fact, in 2016 with Clinton, accurate time was about 2 months before. Those were much more accurate than the ones right up close. And in general, I mean, I did a paper that's in, for those of you who are interested in forecasting, I should mention the journal, International Journal of Forecasting, which I just was stepped down as associate editor, but IJF, the International Journal of Forecasting, publishes papers on election forecasting. And I have a paper that just came out there with Chris Wilazian and Will Jennings. It's precisely about lead time. And we make a case that really, and Colin mentioned this, the trade-off between, there's a trade-off. The closer you get, you generally buy a little more accuracy, but also you lose gravitas, you lose importance. It's theoretically less relevant. That, you know, I'm not interested if you can forecast yesterday what's going to happen today. I am interested if you can forecast it 3 or 4 months before. So for giving up a tiny bit of error, you know, allowing a little bit more error, how far back can you get? And what we see is 3 to 4 months. You can get about the same predictive power 3 or 4 months before. This is over a vast sample, not just the US, many, many countries. 3 or 4 months, you can get accuracy. You get accuracy and you get, you know, theoretical and policy importance. So those are great questions. And I want to say for myself, I know Colin wants to say something, but this has been a great experience. And I applaud your Colloquium series. You're doing a great thing, and it's very international. I hope our both speak Iowa English, which I hope is clear enough. We all than any other English. I hope that you understood us.
Easier to be understood than Texan.
Exactly.
Exactly.
Definitely.
All right. I think this is a really informative and also looking at all this. I just want to add a couple of comments because I think I'm a person doing the polling also. And one thing that maybe I want to add a footnote to Mike's earlier comments about unemployment. I think I remember reading your book in my graduate school days, and unemployment has been a very important variable on your economic voting model. Yeah. So particularly in the European cases, now this US may not be that important until this year. I don't know how much that can be put into the ensemble model that get more improvement to that, because now, as you mentioned, that COVID people losing jobs, they really want to fan out their plight, and this is one thing I think that could explain, or they could actually add up to patch the model a little bit. Now, another thing I want to make is the polling industry, or polling in general, actually could do a disservice to the whole thing, because polling is not independent of the result, so including forecasting too. So because polling provides data for campaign funding, so if you are, for example, donor to either candidate, you see such a polling data, either you say, Biden is going to win anyhow, I'm not going to give him more money than he has. But of course, he has a lot of funding support. But for Trump side, wow, and he's going to lose, and regardless whether I put in money, so I would not donate to this campaign anyhow. So that is something, an argument about polling is doing a disservice, because it's not really staying aside and watching and my hands folded, because you are actually playing the game too. Yeah. And what do you think? And maybe Peter and a team, or maybe have a concluding remark.
Dr.
Colin,
Dr. Chen, ask something.
Yeah. Yeah, I mean, I agree, Carl, with what you were saying about setting expectations in terms of these polls, right? It's not just entertainment or grand, entertainment as you go through the election cycle. You're right. I think people, especially people that are maybe not as engaged in politics as we all are, take those more seriously. And so I think that's a good point.
Yeah.
Carl, Professor Lewis-Beck, very wonderful presentation. Particularly, I'm quite interested in his so-called citizen forecasting. It's very thought-provoking models. And I was thinking if we put some big data information into so-called citizen forecasting models, will it be possible, or it will be more complicated situation? I'm curious because nowadays there are many so-called big data coming out, and I don't know whether it's possible to mix those data into your model.
Well, yeah, and actually they've done a lot. Most of that, most forward is in France. They have explicitly polls. So a friend of mine, a Quebecois, he launched in France surveys that were gathering data, big samples, thousands and thousands and thousands, hundreds, and they predicted the last French election better than by far than the vote intention polls, and it was an explicit drive to collect a lot of data, and it's not as restrictive as this. So yes, I think that's worth exploring, actually. Yeah, that's a good idea. Yep.
Thank you.
Thank you very much.
Thank you for the wonderful presentation. I thoroughly enjoyed it. Thank you. Thank you very much.
Thanks. I look forward to seeing you in person sometime.
Yes, hopefully soon.
Yes. And just one more remarks about a request. Is that possible? Because students are asking that how we replicate the model. Maybe is there's any further information? Probably Clark can help put on the GitHub so that we can try to do some practice here with our classes.
Yeah, I think
I can send Carl the slides and the replication stuff, and also the the Economist model. They have a GitHub page up there, which I poked around on a little bit. I didn't try.
Gelman's GitHub.
It's not his. They have a special one. If you just Google the Economist Model GitHub, it pops up. It's not connected to his one, but I didn't actually replicate it, but in theory, they say there that they have all the code if you wanted to run that model. It is up there, I know.
All right. Good.
Great. Thank you.
Great.
Thank you.
Thank you.
And then,
all right. And
hopefully, we'll see each other very soon.
So
better in person. Okay. And you keep well. Yeah. Thank you very much.
Yeah, thanks everybody, and thanks Carl and Harold for inviting us. Yeah, I hope in person next time.
Yes.
Indeed.
Thank you, Mike.
Thank you, Colin and Mike. Thank you, and have a good night. And here in our city should be about 10 o'clock. Yeah.
Enjoy.
Okay. Thank you, Colin.
Thanks everybody.
So do you. Thank you. Hello. I think I will leave. Still allowed to Peter to maybe take over to wrap up. Do you have anything to conclude about tonight's colloquium?
Well, thank you, and thank you. Thank you for joining us, especially for Dr. Tim Chan. Thank you for being here with us, and hopefully we'll see you very soon for the coming next Friday or next Thursday, actually, U.S. time. Then we will have another colloquium here. We invited Dr. Imai from Harvard University, so please join us if you do have time.
Yes.
You are more than welcome to come aboard and to discuss this. I think that's a very insightful topic too. It's an evidence-based policy evaluation. Please join us. Thank you.
Thank you very much, Peter. Thank you so much for the.
All right. Thank you all. Yeah.
I have to go. Thank you.
Thank you, team.
Thank you, Carl. I appreciate it.
Thank you. Look forward to seeing you next time. Okay.
All right.
All right.